The Earth's surface is 70% water. If you just looked at a map and saw a sea of blue, you might think that the water was just sitting there, but it's not. Oceans are constantly moving, and it isn't just the waves and the tides that move. There are enormous rivers of water flowing through oceans, near the surface and near the seafloor, which influence the Earth's climate and its weather patterns. Learn more about ocean currents and how they affect the planet on this episode of Everything Everywhere Daily. This episode is sponsored by BetterHelp. The holidays are coming up, and it's the time of year when some people feel increased anxiety or pressure. Maybe you're struggling with holiday-induced anxiety or depression. Or perhaps you're just dealing from stress from work or school, or you simply want to prioritize your mental well-being. If that's the case, BetterHelp has a team of experienced therapists who can provide the support you need to navigate life's challenges. BetterHelp is all about making professional counseling accessible, convenient, and affordable. With BetterHelp, you can connect with a licensed therapist from the comfort of your own home via online video sessions, chat, or phone calls. No matter where you are or what you're going through, BetterHelp is there for you. Just fill out a brief questionnaire to get matched with a licensed therapist, and you can switch therapists at any time for no additional charge. Everything Everywhere Daily listeners will get 10% off your first month with BetterHelp. Visit betterhelp.com/everywhere today to get 10% off your first month. That's BetterHelp, HELP.com/everywhere. This episode is sponsored by Factor. I don't know about you, but I enjoy cooking my own meals. However, sometimes you don't have the time to do that. Work and life can get in the way and you just want something fast to eat. Fast food is probably not the best option in such situations. What you want is something fast, good, and good for you. And that is where Factor comes in. Factor is America's #1 ready-to-eat meal delivery service and can help you fuel up fast for breakfast, lunch, and dinner with chef-prepared, dietitian-approved, ready-to-eat meals delivered straight to your door. You'll save time, eat well, and stay on track with your healthy lifestyle while tackling all of your chores this holiday season. Choose from 35 weekly flavor-packed, fresh, never-frozen meals that support a healthy lifestyle and meet your meal preferences, all delivered right to your door and ready to eat in just 2 minutes. Head to factormeals.com/EED50 and use code EED50 to get 50% off. That's code EED50 at factormeals.com/EED50 to get 50% off. All over the oceans of the world, you will find permanent currents of water. These currents move incredible amounts of water as well as nutrients and heat. These currents are responsible for weather patterns, dictate what and where ocean life can be found, and how fast ships can travel between points. Before I get into the details of how ocean currents affect the world, I should explain how they work and why they exist. Rivers flow due to gravity. Water simply flows from a higher elevation to a lower one. However, all of the world's oceans are at sea level. Ocean currents have to be driven by some other process. The process that drives ocean currents is known as thermohaline circulation. I readily admit that thermohaline is probably not a word you encounter every day, but it's just a combination of thermo, meaning heat, and haline, meaning salt. The relevant thing you need to know about the heat aspect of this phenomenon is that cold water is more dense than warm water, and as such, will sink. Likewise, the saltier the water is, or the higher the salinity it has, the denser it is, and the more it will sink. In particular, salt water is more dense than fresh water, and this is why it's so easy to float in the Dead Sea. The reason why salt water is denser is simply because salt plus water is more heavy than just water. So what do these two facts about heat and salinity have to do with ocean currents? Thermohaline circulation gets its start in the polar regions, usually in the North Atlantic or the Southern Ocean near Antarctica. The first thing is that water that flows into the polar regions gets cold, and when it becomes cold, it will sink. However, there's more to it. When sea ice forms, it expels most of the salt in the water, and the ice becomes a solid. The salt that is expelled from sea ice is pushed into the surrounding water, which increases its salinity. This very cold, very salty water will start to sink, causing other water to flow in behind it. And this is how the process gets started. Cold, salty water sinks and begins to flow deep near the bottom of the ocean. The flow will go away from the source of the downwell, generally traveling towards the equator. Warm water will flow on the surface to the polar region to replace the water that is sinking down. The cold, salty, sinking water, however, is only half the story. If there is to be a complete cycle, it will eventually have to come to the surface. So how does that happen if the water is already cold and more saline near the seafloor? This is known as upwelling, and it occurs at the edge of land masses. Upwelling, like downwelling, has two primary causes. The first is simply physical. On a continental shelf, water depths decrease the closer you get to the shore. As the water becomes shallower, the cold water is literally being pushed up a ramp. And the second cause is wind. When the wind blows from the land to the sea, or parallel to the shore, it pushes surface water away. Water from below is literally pulled up to replace the water that was pushed away, sort of acting like a siphon. This cold water, now at the surface, will warm up and start the process anew. This is how ocean currents become a gigantic conveyor belt. I'm really simplifying the whole upwelling process. The Coriolis effect can be involved, and there are other methods of upwelling available, but the end result is that cold water from the seafloor comes up to the surface. And I should also note that the process of wind on the coast can act in reverse as well. When the wind blows from the sea to the land, it can result in surface water being pushed down. The entire process of water sinking in polar regions, traveling across the bottom of the sea, and then being brought up again to repeat the cycle can take multiple centuries. So, why are these ocean currents important? Well, for starters, it's responsible for an enormous amount of life in the sea, and for that matter, on land. If you remember back to my episode on the element iron, iron is one of the key nutrients in the ocean for phytoplankton. Most of the deep ocean is a desert of marine life because there's no iron. Without iron, phytoplankton can't grow, and without phytoplankton, you don't have the basis of the food web for the ocean. Iron does enter the ocean from rivers and other land runoff, but by far the largest source is from upwelling. When water is brought up from the bottom of the ocean, it brings with it a host of nutrients, including iron. Where you find cold water upwelling to the surface, you will almost always find abundant sea life and productive fisheries. Phytoplankton in the ocean is also responsible for the production of about half of the oxygen in our atmosphere. So, no ocean currents means not enough nutrients, which means not enough phytoplankton, which means not enough oxygen. Ocean currents play another vital role. It helps distribute heat throughout the planet. Warm water currents can warm up places that would otherwise be colder and cool down places that would otherwise be much hotter. Weather systems and the overall climate of the Earth are dependent upon these ocean currents. So, what are some specific examples of these currents? Well, there are dozens of identified permanent ocean currents that exist around the world, and some of them are more important than others. The two most important downwells are the North Atlantic deep water and the Antarctic bottom water. The North Atlantic deep water forms in the area off the coast of northern Canada and Greenland. Antarctic bottom water forms all around the continent of Antarctica, and this is by far the largest source of high salinity cold water in the oceans due to the sheer amount of sea ice that is produced around Antarctica. Much of the cold, salty water that is created here winds up in some of the lowest points in the ocean. You might be asking, what about the Arctic Ocean? There are currents in the Arctic Ocean, but it isn't as connected to the rest of the world's oceans as the Southern Ocean is. There's a narrow opening between Alaska and Russia, a couple of straits through the Canadian archipelago, and one major opening between Norway and Iceland. But that's about it. So it plays a part, but it isn't as big of an effect on the downwelling found near Antarctica and in the North Atlantic. There are several places on Earth where you can very clearly see the effects that ocean currents have. Perhaps the most obvious that I've ever observed has been in the nation of South Africa. The city of Durban is on the east coast of South Africa and has a very warm climate. And this is due to the warm Agulhas current, which travels south down the east coast of Africa. However, if you go to Cape Town, you're going to find conditions are much cooler. That's because it has colder waters flowing past it, which come up from Antarctica. This is the Benguela current, which flows up the west coast of Africa. The Agulhas current doesn't make it to Cape Town as it goes south to Antarctica before it gets there. I actually experienced this firsthand when I was camping in the sand dunes of the Namib Desert in Namibia. Despite the fact that we were in the middle of a desert, in the tropics, temperatures at night and in the morning would often be much cooler than what you would expect. The cool waters and hot air would also often result in heavy fog, which we experienced almost every morning. South America has analogous currents on both of its coasts. On the east coast, there is a warm current that flows south known as the Brazil current. On the west coast, there's a cold current known as the Humboldt current that flows north. In the northern hemisphere, these are reversed. The west coast of North America has a south-flowing cold current known as the California current. On the east coast of North America is the very important Gulf Stream. The Gulf Stream has uniquely warm water due to the fact that water tends not to circulate as much in the Gulf of Mexico and the Caribbean Sea. The Gulf Stream goes up the east coast of North America all the way to Western Europe. The Gulf Stream is largely responsible for the temperature climate of Europe, which is far warmer than what it should be given its latitude. For example, London is at a similar latitude to Calgary, Alberta, even though it has much warmer temperatures. The easternmost point of England is the Scilly Islands, a collection of islands off the coast of Cornwall. Because they're out in the middle of the Gulf Stream, the Scilly Islands actually have palm trees, even though it's technically in England. The Gulf Stream is also why it takes less time to sail from North America to Europe than vice versa. This discrepancy in sailing times was one of the things that tipped off scientists as to the existence of ocean currents. I should note that these major currents that follow the coasts of continents usually do not cross the equator due to the Coriolis effect. For example, the cold Benguela current goes up the west coast of Africa and then flows west in the Gulf of Guinea, where it warms up considerably, and then it becomes an equatorial current, going back down the coast of Brazil. Because they tend to loop around at the equator, there exists what are known as ocean gyres. The Earth has 5 great ocean gyres. When the warm Gulf Stream goes up, a cooler Canary current goes down the northwest coast of Africa before again heading west to the Caribbean north of the equator. The North Atlantic Gyre has at its heart a region known as the Sargasso Sea. The Sargasso Sea gets its name from the large amount of seaweed that can be found in the middle of it. The other major gyres are the Indian Ocean Gyre, the North Pacific Gyre, the South Atlantic Gyre, and the South Pacific Gyre. Water in the middle of a gyre tends to be more stagnant, and floating objects, including sailing ships, can become stuck there. In the North Pacific Gyre, this has become a major problem. Millions of tons of floating plastic have caused this region to be dubbed the Great Pacific Garbage Patch. Most of the plastic in the garbage patch is actually quite small, and if you sailed through it, you might not even notice more plastic than usual. While the density of the plastic is much greater than almost anywhere else, it isn't as if the plastic is so dense you could walk across it. And there's a similar garbage patch in the North Atlantic as well. Ocean currents are fundamental to the study of oceanography. The natural forces behind the thermohaline circulation, the changes in water density due to temperature and salinity, drive these currents that shape our world. And it's a good thing, too, because without ocean currents, the Earth would be a very different place. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Peter Bennett and Cameron Kieffer. I wanted to give a big thanks to everyone who supports the show on Patreon. Your support helps me put out a new show every day. And if you're interested in Everything Everywhere Daily merchandise, Patreon is currently the only place where it's available. And if you'd like to talk to other listeners of the show and get notified of future episodes and projects, please join my Facebook group or Discord server. Links to everything are in the show notes.